I'm Anil Kumar. Welcome to my series on pre-calculus. Here are a few questions from one of our students who is preparing for the test. We need to solve equations where we have rational exponents. So there are four equations which I'm going to solve in this particular video. You see part C and D now. You can always pause the video, answer this question, and then look into my suggestion. I will actually begin with A and B, which are much simpler. So let's move on and begin with the basic equation. So here we have two equations, part A and B, where you find the exponents are rational. Let us see how to solve such equations. 26 equals to 27x to the power of 3 over 4 minus 1. We can bring 1 to the left side. That gives you 26 plus 1 equals to 27x to the power of 3 over 4. Now 26 plus 1 is also 27. So we get 27, and here we have 27x to the power of 3 over 4. Now the idea is how to work with these exponents. Now a couple of things to do here, but I think the easiest way is to write this with to the power of 4 over 3, right? So we could write this as 27 to the power of 4 over 3 equals to 27x. Do you get this step? Now this is kind of a critical step at this stage, right? Okay, now what is 27 to the power of 4 over 3? Well, think like this. 27 cube root, right? So we have cube root of 27, which you know is 3, and you can make power of 4 here. And on this side, we have 27x. So what we have here is 3 to the power of 4, right? And here we have 27x. 3 to the power of 4 is 81, right? So it is 81 27x. And so x could be written as 81 divided by 27, which is equal to what? Well, just 3, right? So 3 to the power of 4 is 81. 3 to the power of 3 is 27. So what we get here is our answer as x equals to 3, right? So that is how you solve the very first equation. Now there could have been some shortcuts here which I avoided purposely. But I hope all these steps give you a good idea of how to work with the exponents, right? Now let's take similar question, which is question number B, right? Part B. You can actually pause the video, simplify and answer. So here we have 5 minus 1, bring 1 to this side just as we did there. So we have 5 plus 1 equals to, okay, so we also have a 3 here. Okay, so we'll do minus 3 also. I think there is a typing error. This one is not there, right? So there is a typing error, okay. So it is 5 equals to 3 plus 4, a to the power of minus 1 over 6. We'll bring down this 3 to the left side. We get 5 minus 3 equals to 4 times a to the power of minus 1 over 6. Now 5 minus 3 is 2. So we get 2 equals to 4 times a to the power of minus 1 over 6. Well, at this stage, you can bring a to the side, right? You could do that. 2 to that side. You could do that. So let's do that. So we'll divide this all by 2. And we can rewrite this as a to the power of 1 over 6 equals to 4 over 2, right? Is that step clear? For some of you, that could be confusing, right? So let me split here and provide you with two different solutions, right? That should be a good idea. So let's rewrite this. We could write this as 2 equals to 4, and when we have a negative power, that a comes in the denominator, right? So we have a to the power of 1 over 6. Does it make sense to you? Right? Now we can cross multiply. So when we cross multiply, we get a to the power of 1 over 6 is equal to 4 over 2, which is 2. Does make sense to you, right? So now I think it gets connected. So we can now write a to the power of 1 over 6 equals to 2. 4 divided by 2 is 2. So what is A equals to? A is 2 to the power of 6, which is indeed 64, right? So A equals to 64 is our solution. Perfect. So I'm quickly going through this since it is a review for most of the students and they do have a test tomorrow. So not much time to waste. Now these two questions are done. Let's take up C and D now. So question number C. P minus within brackets something to the power of half equals to 0. So let's bring it to one side. So we'll write this as P equals to within brackets minus 10 plus 7p to the power of half. Correct? Now we could square both sides. So when we square, we get p square equals to minus 10 plus 7p. Remember, whenever you square, you actually incorporate errors. So you need to check your answer for extraneous roots, right? Okay. Now that is a quadratic equation. Bring them all together. So p squared minus 7p plus 10 equals to 0. This could be factored. P minus 5 times p minus 2 equals to 0. That gives you p equals to 5 and p equals to 2 as possible solutions. Correct? Now, it is good practice to test it out. So if I write p as 7 here, what do I get? 7 times 5. So let's check. So if I write 7 p as 5, I get 7 times 5. So I get minus 10 plus 7 times 5 as 35. And then we have to do square root of this, which is 5, right? And 5, that makes sense. That is perfect. So we could check this equation, right? But if I write p equals to 2, then what do we have? We have minus 10 and then 2 will give me plus 14. So that gives me 4 square root, which is 2. And if I substitute 2 and 2, it works. So both are correct. And therefore, in this case, we do have answer, which is 2 and 5. Both are valid answers for us, but it was important to check it, right? You should understand that here, the value of p within the square root, we cannot have a negative thing, correct? So basically, let's go back to this. Minus 10 plus 7p should be actually greater than equal to 0, right? Or from here we get 7p should be greater than equal to 10, or p should be always greater than equal to 10 over 7. Now both these answers were greater than 10 over 7, so they are correct solutions. You get the idea, right? So that makes it correct. Okay. Now let's get back to the last question, which is kind of complicated to look at. Here we have 3 terms and rational exponents. The minimum of this is x to the power of minus half, which can be factored. And 2 is also a common factor. So I'll take 2 x to the power of minus half as a common factor. First term dividing by 2 is 1. So we get x to the power of. Now what should you get in the exponent? We have 3 over 2. We have taken x to the power of minus half, so it adds up, right? Half gets added up. That is what you get in the exponent. The second term dividing by 2 gives you 2. And x to the power of half plus half, which is 1. And the third term divided by 2 gives you 3. And x to the power of minus half has been taken out. So that is what you get. Now let's expand, or rather simplify. So we have x to the power of minus half. And within this bracket, we get 4 over 2, which is x squared. Plus 2 times, here we get 1, right? So 2x. Minus 3 equals to 0. So that gives you 2 and x to the power of minus half. I could write like this, right? Square root of x. Correct? So that is x to the power of minus half. That means x cannot be 0. On this side, 3 minus, we could do 3 times 1. So we get x plus 3 times x minus 1 equals to 0. So those are our factors for the same. Now in this particular case, we do have 2 solutions. So our answers will be x equal to minus 3 and x equal to 1. So these are two possible solutions for the given equation. I hope you understand this particular step where we actually rationalize. And do not write x equals to 0 something in your answer. Remember, x is not equal to 0 for this particular question. Perfect. As then this becomes invalid. So I hope that helps you to understand how to solve equations involving rational exponents. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.